Static friction. Specific learning outcomes. Define static and limiting friction. Solve problems involving static friction. And number 3, obtain the coefficient of static friction mu by performing a simple experiment at home. Motivating or prompting questions. In which of the following situations is static friction present? Number 1, a book is at rest on a table. Number 2, a table is pushed by a boy but never moves. Number 3, you are at rest on a couch. Number 4, a block of wood that is at rest on an incline. Number 5, a block of wood moving on an incline. And number 6, a car that is pushed by its owner and does not move. So, in the following situations, static friction present in number 2 because the table is pushed by a boy but never moves. In number 1, since the book is at rest, then the static friction there is 0, or there is no static friction. In number 3, since you are at rest on a couch, static friction there is also 0. And number 4, yes, there is static friction because a block of wood is at rest on an incline. And with gravity, this block of wood will slide without friction, without this static friction. And number 5, since the block of wood is moving, so there is no static friction, but we know that there is kinetic friction. And number 6, a car that is pushed by its owner and does not move, so we have there static friction. So there are two types of friction, static and kinetic. Recalling from the previous lesson about free body diagram, FBD, there are two types of friction, the static and kinetic. Static frictional force, F sub S, is present when an object is pushed or pulled but never moves. In other words, static friction is not present when an object is left to rest on a horizontal surface without an applied force such as a push or pull parallel to the surface. We say in this case static friction is 0. This notion gives a clearer meaning of static friction, a resistive force. Static friction opposes this push or pull or any other force that would try to make an object move from its state of rest, such as gravity. On an inclined surface, gravitational force may contribute to the movement of an object, especially at greater angles. In both horizontal and inclined surfaces, static friction is present the moment the object is tried to move from its state of rest until or before it begins to move. In equation form, static friction or static frictional force F sub S is expressed as F sub S is less than or equal to mu sub S times Fn, where mu sub S is the coefficient of static friction and F sub n is the normal force. Now, there is this maximum amount of static friction or opposing friction the surface exerts on an object just before it moves. This maximum static friction that must be overcome to move an object is called the limiting frictional force or limiting friction F sub limit. And it is expressed as F sub limit is equal to mu S times Fn. We have already discussed normal force in the previous lesson. On the other hand, the coefficient of static friction mu sub s is a proportionality factor between two materials in contact. Table 4.1 here lists some approximates of coefficient of static friction between two materials or surfaces. We have glass on glass. The mu s is 0.94. Rubber on dry concrete. Mu s is 1.0. Steel on steel. Mu s is 0.74. Aluminum on steel. Coefficient of static friction mu s is 0.61. And wood on wood, the coefficient of static friction is between 0.25 to 0.50. Sample problem 4.1. Find the values of the static friction when moving a 75 kilogram refrigerator with a 100 newtons pushing force without moving the appliance. Letter B, a 200 newtons pushing force without moving the refrigerator. Letter C, a 370 newtons maximum pushing force before it starts to move. And letter D, find the coefficient of static friction mu sub s between the refrigerator and floor. So we have here the free body diagram of our situation. Assuming that our refrigerator is just one particle, letting all the forces act on its center of gravity, we have the forces acting on the refrigerator or our appliance. To the right is our static frictional force. To the left is the applied force. Since here in our example, in our figure, we have pushed the refrigerator to the left. Fn now is the normal force, which is perpendicular to the surface, and Fg, of course, is going down. In questions A and B, the refrigerator does not move. Moreover, in letter C, the refrigerator is just about to move. Because of this, our summation of Fx and summation of Fy will be summation of Fx, forces along the x. We have negative Fa plus Fs. We stick to our sign convention that to the left is negative and to the right is plus x. Down is minus y, up is plus y. Equals, we ask, is this object accelerating along the x? The answer is no. The object didn't move. In all cases, A, B, and C. And also in summation of Fy, it's plus Fn. Fn is going up. Minus Fg is going down. Minus Fg equals, there's no movement along the y, equals 0. So using now summation of Fx, we can obtain the value of Fs when applied a pushing force of 100 newtons. This is what we are looking for in letter A. Find Fs. when Fa is equal to 100 newtons without moving appliance or the refrigerator. So from our equations, FFS is here, so we use summation of Fx. So we just copy that. Let's place here. This will be equation 4.2. The summation of Fx, summation of Fy will be summation of Fy will be equation 4.3. So we have 4.2 to get FFS, negative Fa. I'm just copying 4.2 plus FFS is equal to 0. Transpose negative Fa to the other side, it becomes plus Fa. So FFS equals Fa. Substituting the value of the applied force, therefore FFS, static frictional force, is 100 newtons. We do the same for letter B, but this time the appliance is moved with a force of 200 newtons and still the appliance did not move. So we use again summation of Fx to get the static frictional force between the appliance and the surface or floor. Again, find FFS when applied force is equal to 200 newtons without moving appliance, the appliance. So we can still use 4.2 because without moving the appliance, the term on the right, it will be equals 0. You know that this will become MA if our object is accelerating along the x-axis. But since our appliance did not move, so it is 0 or not accelerating. We copy negative Fs, negative Fa, plus FFS, equation 4.2, equals 0. So again, we are looking for FFS, so we transpose this to the right. FFS equals Fa. And now our Fa is 200 newtons, so equals 200 newtons. For letter C, we are to find the static friction when find static friction or static frictional force when a maximum pushing force is applied. Before it starts to move. So this is now the maximum pushing force before it starts to move. Since this is the maximum pushing force before the object starts to move, our FFS will now be called FF limit, or the limiting frictional force. And we still use the same equation, but we'll just translate FFS to FF limit. So we say negative FA max plus FFS will become FF limit equals 0. It is still equals 0 because our object is still at rest. It is about to move. So solving now for this, again we transpose negative FA max to the right. We have FF limit is equal to FA max. And FA max, the maximum force before the object starts to move, is 370 newtons. Now that we have the FF limit, we can solve for the mu s, or the coefficient of static friction. And this is what we are to solve in letter D. Solving for mu s, coefficient of static friction. And the equation for this is this is actually equation 4.2. We have using equation 4.2. The F limit is equal to mu s f n. We want the mu s, we divide the entire equation by the normal force Fn. So Fn over Fn, that's 1. So that's why mu s is F limit over Fn. So for FF limit, we have obtained this one, the previous item, letter C. We obtained 370 newtons for our FF limit in this problem. We have FF limit, but we have no Fn yet, normal force. Now to solve for normal force, we have to look again at our free body diagram and the equations that we have made. I'm going up here. Normal force actually is the force perpendicular to the surface going up. Fn. It is in summation of Fy equals Fn minus Fg. In other words, we're going to use this equation summation of Fy in order to get our Fn. Fn minus Fg equals 0 in the summation of Fy. Fn minus Fg equals 0. solving for Fn using summation of Fy. We have Fn minus Fg equals 0 in the summation of Fy. So we want Fn, we transpose this to the right, the minus Fg. So it becomes Fn equals plus Fg. But we know that but Fg is just equal to the weight. Fg is actually the weight. Another term for gravitational force is the weight equals mg. And we substitute the mass of our appliance, which is 75 kilograms times g, the acceleration due to gravity. Now you just place positive, do not place a negative because the negative sign has been taken care of in the free body diagram. So you just place here, weight is always, use always positive g in calculating for the weight. So 75 kilograms times 9.8 meter per second squared using your calculator, you should get an answer of 735 newtons. Now that we have Fg is equal to Fn. Okay, so we write Fn is equal to Fg. So we write Fn equals Fg is equal to 735 newtons. So we now have Fn. We substitute now the values that we have. For FF limit, we have there 370 newtons, 370 newtons. Divided by Fn, 735 newtons is our mu s. So newtons divided by newtons, that's 1. You execute this using your calculator. 370 divided by 735, you should get an answer of 0.51. Notice here that the coefficient of static friction has no unit. It's 0.51 in our case. Thank you for watching.